Hi everyone, welcome to today's video. Hope all of you are doing great. All are going good. So this is one of the MPLS series video, and this video is designed such a way so that anyone can learn from the scratch to advance. And this video I have designed with theory and the practical. I will show you the lab in between each topic or each sessions. All right. So today's video is discussion is on the topic is LDP, right? So LDP is nothing but label distribution protocol. So as its distribution, let him distribute. We'll focus on understanding the label distribution protocol. But before jumping into that label distribution protocol, what we will understand why label, what is the advantage and why distribution. I will show you with a realistic example, very simple example to you so that you can understand easier way, right? Just let's say you have two delivery boy, right? And you give both of them two different envelopes, right? And you ask both of them to deliver a specific address or destinations, right? But you have mentioned that address within that envelope, right? Inside that envelope. Now what first delivery boy did, he put one label top of that envelope and he has delivered that packet to the destination. The second guy open that envelope, see that address, then again close that envelope, then he has delivered that address. Now it's bit less faster than the label switching, right? So hope we understand why label, right? So label is make the faster delivery, right? All right. So here from now and onwards we'll understand this is not router, we'll consider as the LSR, label switching router, right? Any router which is part of the MPLS is called as LSR, right? And the path through which this packet been delivered, this is called as LSP, label switching path, right? So we understand by using the label the packet can be delivered faster, right? And label is required for the faster delivery. Now still if you have any confusions, you doubt, you can keep the picture in your mind, the next picture, right? So you can think for now that same thing happened inside that router. Some machine is labeling each packet and distribution the label also, right? This is how the LDP work. For now you can understand or you can keep this picture in your mind. Now from where this protocol LDP derived, all right, we'll understand that part, right? As you know, it's the Cisco initially lots of protocol has been delivered, then it's later on it's made standardized by the IEEE, right? The same way Cisco build this protocol TDP, then it's made standardized with the IEEE, that is the LDP, that is the open source, everyone use this protocol, right? Now you can enable or disable this thing, or you can use both of this naughty boy, right? So router, you have to put the command router MPLS label protocol, either one anyone can choose, and both you can choose, right? The example I can give you another example like ISIL PGP initially built by the Cisco, then it make later on it's make standardized by the IEEE. The same way TDP also done. So we have one not complete, it's a hazy picture you can say. So this is how it's been worked. Now let's move forward. Now we understand the better way, right? The real way. Now before explaining the LDP, LDP is nothing but a protocol similar to OSPF, BGP, all these stuffs, right? They also build adjacencies, right? They also build neighborship. Similar way, the LDP also build neighborship, right? They do the other protocol exchange the routing, the LDP exchange the label, right? In this slide, I will explain LDP working mechanism to you, how it's work. Basically, the LDP works in three way or three phase: discovery, sessions establishment, and the label distributions. The three phase the LDP works initially, right? So we'll understand one by one each the phase, right? So we'll focus first phase is the discovery, right? So I hope you are aware about the OSPF protocol, right? First they discover each other, then only they establish the neighborship. The same way you can think, the same way over here happen also, right? So how this MPLS initiation start, that we have to understand. Whenever we configure MPLS IP on that interface where your neighbor directly connected or another router is connected, instantly this interface or this router become one group of MPLS multicast IP, that is 224002, right? In OSPF they do use 224005. Here for the LTP we use multicast IP 224002, right? So what happened basically, once I configure the MPLS IP, it's become that interface or IP in a multicast group. Then what they do, they instantly sends a hello message. How do they send the hello message? Using that UDP and using that port 646. Always it is standard for the LDP, right? Similarly, you can think in the BGP they use 179, right? So we understand they do use hello message for the discovery. They generate the packet, then they exchange or they send to the multicast IP, or the group were the part of this multicast IP, right? So once they receive that hello message, so that they discover each other. But before that, they has to compare the hello message. Now you are a bit curious to know the what this hello message basically content, what it sends in that envelope, in that hello packet, right? Now I am going to explain the hello message over here. So inside that hello message, these are the component or these are the message, sub message being sent within this hello packet, all right? And I will explain each and every part over here. So as you know, LDP version, right, or like you can compare with the other routing protocol, right? BGP, they also exchange the version. Also here also they exchange the LDP, label distribution protocol versions, right? They says my version is 1 and he says my version is 1, the first criteria, all right? Then they do exchange similar way the PDU length. It's very well known, right, for every protocol data unit. So that been also exchanged within this hello message. Apart from that, another thing they do exchange, that is LSR ID, label switch router ID, right? In BGP or other protocol, we do use router ID, right? Here we will use LSR ID, right? As I said, we'll forget for now router, we'll always call as a LSR, right? And that is 4 byte over here, right? And the second part, or probably it is fourth, basically the fourth component or fourth message content is the label space. Now it's bit important, the label space. But before that, I would like to highlight one thing, that is the LSI ID, how it's been chosen, right? Similar way, the router ID is being chosen the highest loopback IP address. If it is configured, if it is not configured, then it's choose the highest interface IP address for the router ID or LSR ID. This is how it's been chosen, right? Hope you understand. Now we'll focus on the fourth, as I said, the level space, which is very important. Excuse me. Now here always you can see two value only, either 1 or 0 or 1, right? These two value you can see. But here is meaning behind this, right? If it is 0, right, for any router, let's say this router, if it is 0 value in level space, whichever they exchange the value, if it is 0, in that case the label are being assigned on basis of platform basis, right? And if it is the value exchange, the 1, in that case the label been exchanged and swap or all the steps will be based on the interface wise, each interface, right? Hope you understand, right? So the value, mostly we use value 0 in our MPLS, but in ATM and other part we do use value 1 for the interface base level space, right? Or a level generation, level tagging, all this stuff you could say, right? Hope you understand. The 0 means platform wise label assignment, and the value 1 means interface wise label assignment. You can think like this way. All right, so hope you understand. This is one of the sub message or content that is the label space, and that label space being exchanged within themselves, right? And the fifth part you can say that is the hold timer, like similar to other routing protocol, VGP and other stuff. They do use hold timer. For here it is the 15 second that do use. For other protocol 18 or other times they do use. For the LDP they do use 15 seconds mostly. Another thing, or the sixth thing they do you exchange, that is the transport address. Now what is the transport address? Basically this transport address decided on based on the router ID mostly, right? And this LDP or LSR ID, it's not router ID, it's LSR ID. As I said, always we'll tell this LSR ID or LSR. So LSR ID is being choose always as a transport address. Now this, as I said, the LSR ID or the router ID can be choose from your loopback interface. But thing is that if you have multiple loopback interface, right, in that case what will happen? But you are planning to the second loopback interface IP address would be for the LSR ID. In that case you can choose by the putting one configurations that you want to choose the second loopback IP as your LSR ID, and that will be choose as a transport address as well, right? So this is how you can understand the meaning of this content of this hello message, right? Hope you understand. The hello message being exchanged, but hello message contain this much informations to discover each other, right? Now another part is very important, that is extended discovery mechanism, right? So what is extended discovery? Like we are a bit familiar with our other routing protocol, that if any router is not directly connected, in that case also we can establish a neighborship. The same way you can think over here also. Extended discovery is nothing but if any LSR is not directly connected, it is connected somehow with other router or other network, right? In that case also you can establish a extended neighborship or extended discovery, right? For that, in that case you have to configure a few more configuration line that I will also explain. But here what will happen in exceptional in extended discovery mechanism, in that case we are not going to send this hello message in multicast IP. It will be specific to the unicast, right? So it will be definitely unicast, and for that we have to configure two line, like you have to configure from the source MPLS LDP neighbor, that is 3333 targeted LDP, and other end you have to configure the MPLS LDP discovery target hello accept, right? So that he can accept the hello message whichever generated from the LSR2, right? And other configuration you have to configure one tunnel line, right? This much you have to configure so that the LDP neighborship or agencies can be established within within not directly connected network, right? Hope you understand the extended discovery mechanism. Hope it makes sense, right? All right, so if you want to understand more, if you want to read more, in that case you can go through this RFC, right? RFC 5036, right? You can go through and you can learn more on that, right? So hope we understand. Initially the discovery mechanism, they discover, they exchange using port 646 protocol UDP, and they carry the hello packets, right, for the discovery. And this content is this, they do exchange in the hello packet also. But thing is that after successful discovery, what is happened, then next phase goes the session establishment phase, right? As I said, there is three phase: discovery, session establishment, and the label distributions, right? All right, so what happened in this phase? Basically try to understand. One router elected as active, another one become passive, right? The same way you can understand BGP, the same way happen. One router elected as a highest loopback IP or highest interface IP chosen as a active, right? And passive. Active passive is nothing but it active router elected to initiate the TCP connections, and passive router plays a role as a server, and the active plays a role for the client. He initiate the TCP initiations sync request to the server, that is take as a role of passive, right? Hope you understand. So once this router, the 2.2.2 become active by comparing the interface or loopback IP address, whatever it is, what he will do, he will initiate a TCP sync to the server, and then he will receive a synact, then he will act, right? Same, we are very much familiar with the synact, right? And here in BGP we have seen it is use 179 port. Here it will be use 646 always for the destinations, and source will be a range of available ports, the similar to BGP TCP synchronizations, right? But thing is that once this TCP three-way handshake gets successful, what happened? But before that, you have to understand, in discovery phase, we have selected the transport address, right? And this synact all happen based on the transport address. That is why the transport address initially been selected in previous phase, discovery phase, right? They do exchange, they do select the transport address, and top of that they initiate this TCP three-way handshake, and top of that they select the active and passive, right? So after this three-way successfully three-way handshake or a three-way TCP establishment, what happened basically? Let's understand that part also. That is very important, right? So first, the passive one initiate another message that is called LDP initializations message, right? Now this LDP initialization message contains also the same thing, whatever the hello message exchange, more or less, right? They do also again exchange whether all are parameter each other correct or not, equal or not. So what this passive sends a LDP initialization message to the active boy, right? Now he receives the packet. After analyzing, if everything is perfect, right, version, all these stuff, router ID and all this stuff, blah blah blah, then what he does generate another initialized response initialization message with additional keep alive message, and it sends to that another router, and immediately he sends keep alive message, then it's established a LDP adjacency establishment. All right, hope you understand, right? This makes sense that this phase are going on. Initially TCP three-way handshake gets successful, they the one router exchange the LDP initialization message, they do received, and in response of that they send initialization message along with keep alive message, right? And after receiving that router, he also sent only simple keep alive message and this adjacency establish or neighborship establish, right? Hope you understand. Now what happened in this last phase, label distribution phase, right? In this phase, after establishment of neighborship, they do exchange label, right? In other protocol, what happened? They do exchange the routing informations. Here they do exchange or advertise the label, right? But before that, I would like to make you familiar with few different terminology, right? One you can see as a FEC, right over here. Here FEC, and upstream and downstream. Now what is APC, what is upstream and downstream? FEC is nothing but a group of IP packet which are forwarded in the same manners, right? It's treated the same manners over the same path, right? And with the same forwarding treatment, right? So it's been, then only it is considered as the FEC, right? Forward equivalent class. In that case, like here we call NLRI, right? In BGP, we remember this thing. Over here we call is it as a APC, right? But APC only considered then when it is been considered or treat as the same IP packet, or forwarding treatment would be same, right? Now what about the LSR upstream router, and what about the downstream router? Now always upstream and downstream will be considered based on the APC. Considering this APC which is closer to this APC, always called as a downstream, right? So he is closer, he is down to this APC or this prefixes, right? Hope you understand. And for this router, for this LSR1 will be treated as an upstream router, and for LSR1 it will be treated as a downstream router, the LSR3, right? Same way the router 2 will consider in terms of FEC, it will consider as a upstream router, right? And for LSR2 it will consider the LSR3 will consider as the downstream router. So hope you understand the downstream, upstream always consider based on the prefixes or the based on the FEC, right? Hope you understand. Now we'll understand how this label basically being distribute, right? Basically there is two way to distribute the label, right? One is the DoD model, another one is the DU method, right? Downstream on demand, DoD, this is called DoD, and the downstream unsolicited, right? This is called DU. Now how they do work, let's understand the first one. First one, the name as implies the meaning that downstream on demand, right? So to get that label of this FEC 192.168.10, the upstream router must to send one, he has to send one request, he has to demand, right, label request for this particular FEC, right? For this FEC, just a minute, let me take white color. Yeah, so for this FEC he has to send one request for the label request, you can say, right, or demand he has to send to other router, then only the label will be advertised. So what happened over here in this phase, the LSR1 sends a label request for this prefixes or this FEC 192.168.10 to the LSR2, right? So once the LSR2 receives the request, he will receive, and he will also generate one request to the LSR3 for the labeling, right? He router 3 give me one label for this APC, right? Once this LSR3 receives that request, right, he will assign one label and send as a label advertisement to LSR2, right? So once he receives, he will make or keep this label to his database, and he will generate another label from him by himself, and it will send across to the LSR2 or sorry LSR1, right? Hope you understand the way. First they send the request, and against that request they generate label and they send it across, right? Now what happened in downstream unsolicited, there is no demand, right? No one will demand for the label, only this downstream router will assign label and he will send to other router, the same vice versa will goes on, right? Hope you understand the two way the label being distributed. So this is the last phase of LDP protocol establishment, right? Hope it is informative and makes sense. Now we understand in this three pairs what are the message being exchanged. So these are the message being exchanged during or after establishment of LDP neighborship, right? Hope you understand and makes sense. You can take a snip of this table for your reference, right, so that you can understand. So notification message, or let me change the color. Okay, yeah, So the notification message, right? Its notification message is nothing but similar to BGP also. Any significant event happens, it will automatically notify with the notification message. The hello message, as I have explained, the LDP hello message exchange as part of the LDP discovery mechanism. So with this hello message, they discover each other, the MPLS IP enabled or MPLS enabled router, right? Or LDP enabled routers, the very simple way. Now initialization message, as I said, the same way it's initialize, right, again with the content of the hello message, whatever it contains, right? Then it sends the keep alive message. Keep alive message nothing but a signal, so that each other can be sync, right? Can be sync whether the far end or neighbor is alive or not. Very simple way. The address message, right? This part is bit important. Address message being sent, and this message contain whatever the router sends. It sends all the interface connected with him interface IP addresses. I will show you that also, right? So address message nothing but with this message router sends the interfaces IP addresses or prefixes whatever is connected with this router. And address withdraw, right? We learn NLRI withdraw in BGP, right? In that case, the same way happen if any network or prefix is deleted, right, removed. In that case, the withdraw message notify please withdraw this prefixes no longer available, right? And label mapping message, as I said, one label request goes against that request, it sends a label mapping message. Another way in unsolicited, in that case there is no request goes on, only it sends the label mapping message. And we mostly use in Cisco router the downstream unsolicited. There is no demand, there is no request, it sends only the label assignment, right? And abort message, it's also important. If it is any label request is outstanding, in that case it will abort, very simple way. And withdraw message, okay. Address withdraw and label withdraw. If address withdraw, only if you delete any prefixes or remove any prefixes, in that case it will be generate. And label withdraw, if you delete or remove no label assigned, in that case withdraw message will be goes on, right? You can learn more in this RFC 5036, more clarity, right? Now I will take you into the lab so that we can understand each and every message and how the neighborship it gets established, right? So let me take you to the lab only. Here you are. This is the lab basically. Let me have a quick introduction with this lab to you. So here you can see the red circle, all this LSR are MPLS enabled or LDP enabled, right? And these are the customer edge router and the customer end, where I have selected as a source and destination for testing all the stuff, right? And I will show you how the configuration it is, right? So let me take you the configurations. Here is nothing I have configured. Very simple, right? The configuration part is very simple. You don't need to worry about the configuration for now, right? For now. So the MPLS IP only enabled interface. Another one is the MPLS IP, and I have advertised the interface prefixes with the IP OSPF area 0, right? And through this only it's being advertised, and the neighborship is already established. The underlay, you can say, the connectivity reachability, then only the prefixes is get advertised. Now LDP is running top of that, right? So that I will show you over here. Now what I'll do, as to save time, I have already configured the MPLS IP. Now again what I'll do, I will disable this part, right? So which interface is MPLS enable? Both the interfaces, right? This is let me log in this router also. Just bear with me few seconds only, man. Yeah, so here you have two router console login, right? So let me show you again. This is the router, and this is the router, and I will show all this LDP, these interfaces, right? Here only the LDP being exchanged. So what I'll do, I will first disable, right? You can see, so MPLS LDP, like other routing protocol neighbor, right? It is already established, right? Here also, so MPLS LDP neighbor, right? It is also established. Now here I would like to one thing I forgot to show you, that is this LDP ID, right? How this LDP ID being choose and how it's selected, right? LDP level distribution protocol ID, how it's choose. First it's take the LSR, right? Then it's take the level space ID. Now if my LSR ID is 1.1.1.1 and level space is 0, then it looks like, now this entire value would be my LDP ID. The same thing you can see over here, right? 3.3.3 then colon 0. This is called LDP ID. So yeah, so what we'll do, we'll disable that LDP. Do show IP and verif, right? Which interface it is? It is this interface, right? Sorry, yeah. So what my objective over here to showcase to you, that is I will disable the LDP protocol. Then how do I disable? No MPLS IP, sorry. So this is the command through which I can enable and disable the LDP on that interface, right? So first I will disable, then I will enable again, so that each message you can see, right? So after putting this command, you can see this LDP neighbor is down, right? It is goes into down state. Now what I will do, I will capture this interface to check all or capture all this message, right? Whatever I have show you, it is 1/2, right? Let me run Waxark. This is the great tool, right? Yeah, so what I will do over here, let me bit more. I will enable MPLS IP, right? Sorry. So here you can see only OSPF message is being exchanged, and that is also hello packet. There is no LDP being exchanged. Now what I'll do, I will enable the MPLS IP. Oh, sorry, MPLS IP in that particular interface, right? So I have enabled. Now let's see what is happening over here. Yes, LDP is hello message being sent, right? Immediately all this mechanism done, right? Your discovery, or whatever I have explained one by one, each already completed. Now let me close it out or stop it out, right? So let's focus this part, right? So what I said, content, LDP versions, PDU, LSR ID, level space, hold timer, transport address. All these messages or this information being exchanged within the hello message. So I will check the hello message only, right? First, so who sends the hello message first? This is ready, right? 2.1, he sends the hello message. I will open this hello message only. Let me open, I have opened. Let me expand all this field, right? Now here is the main fun, right? As I said, the LDP version, PDU length, LSR ID, level space ID is 0, right? It's 0, that's what it's mean. The label being exchanged or generated on the platform basis, right? So these are the thing being already exchanged. Another part is what? That is the hold time. As I said, 15 seconds, right? 15 seconds, and in BGP we have seen the 18 seconds of probability, right? And the most important part, they have selected or they exchange the transport address, right? He exchanged the transport address, so he received. Now let me close. So all these stuffs is completed. 1 2 3 4 5 6, right? So same thing over here also. 1 2 3 4 5 and 6 all being exchanged already along with the hello message. Now after hello message, what I said once this hello message being exchanged each other, right, they will try to establish a TCP three-way handshake, right? For that, what will happen? This 3.3.3, he is the highest loopback interface ID. He choose as active and he sends a destination 2.2.2 the SYN request. You can see over here SYN, right? Let me show you. This is the SYN request, and who sends? He with the highest loopback IP address, he chooses active and he sends to the destination 2.2.2 as a passive, and this is the SYN request. Then what happened? SYNACT. Who sends SYNACT? He sends SYNACT the 2.2.2 to the 3.3.3, right? And against that, again 3.3, what he sends? Acknowledgement. Now this portion explain very well, self-explanatory, that SYNACT been done, right? So hello message exchange, SYNACT, the three-way 3CP handshake done. Now what comes in picture? The initializations, right? Now we'll open the initialization message. The 3.3 sends the initialization message. Try to understand this. 3.3 sends 2.2.2. Let me take you to the topology again for your understanding. 3.33 sends 2.2.2, right? Hope you understand. What he sends? Initialization message. Let me open that initialization message. What again, as I said, the hello message, whatever the send or exchange, most of the information they again exchange to cross check, right? And these are the initialization message content, right? Along with the LSR ID, label space ID, PDU length, and the version, right? Makes sense, right? Now after once this 2.2.2 receive the initialization message, what he sends, as I explained, initialization message with keep alive, right? Very important, right? So he says initialization message, not only initialization message, he sends the keep alive message as well, right? And these are the information which was earlier sent in hello message, right? Hope it is clear, right? Makes sense. I hope you are enjoying video this, right? Now what left? Then again, after receiving this initialization message along with keep alive, he sends a keep alive. As I said, the same thing. He says keep alive message along with the initialization message, right? Against that initialization message. So what we understand, first hello message being exchanged, LDP three-way handshake gets completed, initialization message and initialization keep alive message, then only keep alive message being sent. After sending this, the neighborship established, right? It's successfully established. Now after establish, what will happen? As I explained, right, they will exchange, or they will they will exchange the label, right? They will distribute the label, right? Now how the label is being distributed, let's understand this part, this field. Now 3.3.3, the right hand side, distribute the label. This is the address message first, label message, and the mapping message. All this stuff is over here, right? So 2 to 3 things. See, try to understand over here. Address message, as I said, address message, nothing but an interface address, and then again label message, label mapping message, all this label mapping message, multiple label mapping message he has sent, right? So let me take you to the message field. Before that, let me open it, right? Just give me a moment, please. Yeah, here it is, right? All this message detail, right? We'll understand each and every message over here. So first, as I said, address message. What is address message over here? Where is the address message? Here is the address message. Address message says LSR send address message LDP peer the advertise the interface addresses. So let's see what he has sent. Who sent the 3.3 to destination 2.2 address message. Let's see the address. These are the attached interface address, right? Whatever the interface address he has exchanged with his peer router within this address message, right? So let me check you again. Sorry, let me show you again. Right, so what are these address? 3.3.3, 330.1, 20.2, 20.1, right? The same thing you can check over here, right? See 20.20.20.20 this, and 30.30.30 this, 10.10.222, sorry, yeah, this is, and the loopback IP address. So within the address message, what he has exchanged, all the interface connected interface message, right? Now second thing is that label message, right? This is the label message. You can see, let me open only one single label. See here I have opened the label message. Here you can see the APC element, right? So APC element is nothing but 2.2.2, right? And what is the level? That is 303, right? So he has advertised one level with the prefixes, that is 303, right? Oh, not only this, let me show you another one. Yeah, so 4.4.4 he also advertised, because he has learned from other router and he has advertised this 3.304 label, right, for this APC. So label distribution has been completed with this message, all right? So label distribution already done. Now I will show you another thing, that is the label withdraw message. How you'll check? Let me show you again. Let me close this out. Just a minute. Yeah, how do I do that? This interface is not needed for me. So what I'll do, I will remove that address, right? No IP address. But before putting this command, let me capture it again. Which one interface? 1/2. Yeah, so it is going on. So what I'll do, I'll remove this no IP address, right? See, LSA already, before that LSA already OSPF does his work, right? Then only LDP is working. Yeah, here it is, right? So 3.3 says I have removed the interface from that 3.3.3. Here I have removed this prefixes. Then immediately he sends to 2.2.2. You can see, let me take the pen. He sends from 3.3.2, he sends to 2.2.2 his peer, stating that some address been withdrawn, right? And this is the address what I have removed, right? Now I will show you again. If it is again I advertise. Okay, so IP address 20 to 20 to 20 to 20. Just a minute, please bear with me. You will enjoy definitely. So let me capture over here again. Yeah, so let me put this IP again. LSA will do his fast work. LSA already advertised with the OSPF protocol. Here is the address message. So one I show you withdraw message, another one is the address message. Again he has sent the address message where he has advertised own interface IP address, that is 2.20.20.20.1, right? Hope you understand, right? All this stuff clear, right? The address withdraw message address message, keep alive message, hello message, initialize message, all this stuff I have shown you, right? So I don't want to waste more time on this single topic, right? Hope it is informative. All right, now we'll understand how they do store all these informations, right? But before that, let me show you something. So tell me one thing, as a network engineer, right? As a network experienced engineer or new fresher engineer, what do you think and what comes in your mind with this picture only? If you understand, if you correlate with this picture something, right, then put in comment box, right, comment section, just put your comment, your understanding before my explanations, right? It will be really appreciable if you understand this stuffs, right, before the explanations. Then it will be really appreciate you appreciate yourself that you really love network, right? So that will be really appreciable if you understand before my explanations what is meaning of this picture, right? So let me explain what is the meaning of this picture. You can see, right, train track, some signal is there, right? Now as you stand in the railway stations, what comes in your mind with this picture? Let me show you that part. Train is similar to IP packets. The available track is similar to RIV or routing information base, and through which your IP packet goes on, train goes on the track, that is called forward information base. And the signal is definitely interface status, right? So hope you enjoy this picture, right? You never forget, right? If anyone learning or watching this video and it is first time for your learning network routing information base, forwarding information base IP packet, this picture itself a self-explanatory, right? So here I have compared this train is a IP packet, right? Whatever available track you have through which currently the train is not going, that is called RIV, routing information base. It means you have this much of routing path, right? And the through which your IP packet or train is traveling, that is called forwarding information based, or this is the based path or safe table, right? And interface status, definitely this is very related to your signal to interface status, right? Hope you enjoyed this session, right? So how do you understand whatever the available track is considered as RIV, right? And whatever the track this train is going through, that is called as a FIB. The very similar happen in MPLS LDP table also. Here this RIV is called over here live level information base. Instead of routing, they do store a level, right? And they do store level forwarding base in place of the routing information routing forwarding base, right? So this is how you initially you can understand, right? Hope you enjoyed the video. Now the same way, let me explain more in depth. This is how the LSR table do maintain the table routing and the level. Just imagine or just consider this whole as one LSR, wherein your routing, any routing protocol, right, any routing protocol could run, which help you to build the RIV, right, routing information base. Here is AD, all right. So based on that, they create which one is the best path that is installed in the FIB or safe table, right? Forwarding information base, forwarding plane, data plane, whatever you can say. And the LDP do very closely work with this RIV and FIB to build the LIV and LFIB, right? So this LIV is built with closely work with the help of the RIV, right? Then with the help this LFIB is built, right? And this how this LFIB built with the coordination with FIB, right? Here each and every one coordinate each other, and they do maintain a very nice table, leave a fib and l fib, right? And there is one dotted line, I would say, right? Each other needed to establish or show so to maintain a very well table, level distribution table, right? So that packet get forward, right? So hope you understand, hope you enjoyed this section, right? And let me show you how do you check the lfib and how do you check the leave. Let me show you that part also in lab. Here it is. Let me log in any of the router. So MPLS LDP bindings, right? This is the command through which you can check your what level information base, right? You can see this is the prefix or FEC which is binded with multiple level, right? 3, 9, all these stuffs. Now using that leave and with the help of rev, it's build one LFIB, right? What is LFIB? Level forwarding information base with the help of rev and fib. Now how do you check that part? So MPLS, just a minute. So MPLS forwarding table. This is the command. Very simple. Now this is your LFIB, right? This LFIB built with the help of home, rev and fib, right? Here you can see this is the local level. I will explain more on detail. There is prefixes and this interface and next hop is also mentioned, and that is been collected with the help of but rev and fib, right? All right, hope you understand this part. Now let me explain the very exceptional thing. You might not seen this stuff. How this as you have considered this is the whole router, right? Now if any IP packet or MPLS packet get forward through this router, how it looks like, right? Now let's say I will explain red packet is IP packet, the blue packet as a MPLS packet. First let me explain the IP packet. IP packet sends its look up the fib, then it sends the packet directly, right? It's not needed to look up the lfib, right? Now if I send the MPLS IP packet, what will happen? It goes, it no need to fib table check, it look up the lfib, everything is there for him, right? Then he sends that part, right? Hope you understand. For the IP packet, label is not required, right? That's what fib is enough for him. And for the MPLS packet, label is very much required. That's what he look up for the lfib, right? The same thing, let me show you in lab. Okay, just give a moment. I will explain you. So here, before that, let's try to understand this source 1.1 and this is the destination 8.0. Once this source wants to reach this server, this is MPLS packet, right? And which one is the IP packet? This guy. Now if he wants to reach the same path to this buddy, right, to his friend he want to reach, in that case that will be the IP packet. This is how I have configured, right? Now how do I show you IP packet and the MPLS packet? Let me show you. I will ping. Now consider one thing, that the IP is 8.8.8 and this PC IP is 192.168.3.10, right? Let me show you, right? So what is that? IP address 3.10, right? And his IP address 8.8.8. Now what I will do, let me show you. First I will ping 8.8.8.8, right? It's reachable, right, from this router. So let me show you again, otherwise it might create confusion for you. So I am trying to reach both of them, right? IP and MPLS packet, right? All right, so first I have check this is the router I'm showing, right? So first I have checked my 8.8 is reachable. Let me ping 192.168.3.10. so that is also reachable, right? So first trace me the 8.8.8.8 how it gets forward. First check that part, right? Please bear with me, it will take time. I might pause. If it is fast, then I will not pause. You can skip for a while. Right, so here I will show you how this two packet going forward, right? So where he is going, first he went to, let me show you, first he went to 10.2, right? 10.2, again he 20.2, then again he 30.2, then again he the downstream router, right? So it is there. Now let me trace the IP packet. First one I have traced the MPLS packet, the second one I am tracing the IP packet, right? Let's trace. So from where I'm tracing here, here and here, right? My objective is to trace this. Please bear with me a few times. Yeah, so it is reached successfully. Now let me explain over here for you. So this is, as I said, MPLS packet, right? So in MPLS packet, if you see every hop he need one level, right? Again level, right? Then only he reach the destinations, right? So this much level he do require. That's what he has to look up in the LP or LP level forwarding information base, right? But thing is that once it is IP packet, in that case he no need to look up in the LFIV, he only take the FIV only, right? Routing information be already needed, he don't need any level, right? So this is how we understand the packet forwarding, what we have explained. Now how do I make the IP packet and MPLS packet, that I will explain to you. But for now you understand the flow, right? And how the table being built, right? All right, so now what next? Now next we'll understand more important part. What is that? That is the header, right? Header part is very important. So let's focus on MPLS header, right? Yeah, so here we'll understand bit different way, right? It more easier way, more with adding more fun, right? So here for timing, let's forget about the IP routing. Just take an analogy with a rocket, right? Most of the time we heard this satellite being launched, this rocket being launched, right? So what happened over there, right? Payload, right? What is the payload? Payload is nothing but your main satellite, what you want to launch, right? In the rocket. And the networking IP header, it is nothing but your packet, right? The same way you can think. So payload is nothing but your original data you want to send. The similar way they send the satellite as a payload, right? Now only payload you cannot send, only data you cannot send, you need some supporting, right? So what are the supporting? Who will say where to go, which orbit you have to go, which port interface you have to go? Someone need to help, right? So who will help? these two header will help, right? So L3 header and the L2 header, right? L2 header works for the L2 addresses, right? Where to go and how to go, and L3 header will say you what is your destination IP, what is the source IP, all these stuff. Then only you can send your data or payload, the actual data, right? Now here you can compare with the this is the data packet, right? Entire packet. So you can consider this is FCS, right? Frame check sequence or CRC rather, and this is your preamble, right? So this is how you can understand, right? So you want to send the actual data payload with the help of the L3 header and L2 header, right? Now what is the payload in our networking terms? That is the original data, and layer 3 contain the source IP, destination IP, and layer 2 header contain the source MAC and the destinations, right? Very easy and simple, right? With different way. Now what about in MPLS? This is the on general IP routing packet, right? And what about in MPLS? What happened in MPLS? How it's travel and how it sends the payload, right? Let's focus that part. In MPLS, there is another header come in between L3 and L2, that is MPLS header, and this MPLS header sometimes called is as a 2.5 header, because see this header work in between the layer 2 and layer 3. It's not purely layer 3, it's not purely layer 2, so it's work in between layer 2 and layer 3, and other header or work as it is, right? So always we check the label header part, then we send the data, right? So this is how you can think in MPLS header payload, L3 header, L2 header, and between another header is comp MPLS header, which is called 2.5 protocol or 2.5 header. This is how you can understand, right? But before that, I would like to leave one note over here. That note is very important, right? So who will understand which type of data it is, which type of packet it is IP packet or MPLS packet? Who will tell you, right? Now let's check this part, right? So the protocol field in layer 2 header, right, in PID field of the layer 2 header specify whether it is IP header or whether it is label encapsulated or MPLS encapsulated. So what is this value? If the PID is 0x0800, in that case it will be considered. It will not be considered, it is, right? It is unicast IP address, right? And if it is the value is 8847, in that case this is a unicast MPLS packet, right? Just now I have shown you some two comparison, IP packet, the MPLS packet. Now how do you understand, how you will understand that whether it is IP packet and whether is it MPLS packet, right? How the PID value you will tell you whether it is IP packet or MPLS packet. Just let me take you to the example which I just show you for the live and flip understanding, right? So how do we understand, right? Let's do one thing. Let's open this body, right? All right. So we will ping, right? Not this router. We'll ping from here also, right? This is your 172.16. Right? So IP, this is source of the MPLS. So IP, this is source of your IP packet. All right. Now they will try to reach MPLS and the IP packet. Let me show you ping 8.8.8.8c1. Same way I will ping the IP packet destinations 192.168.3.10 c1, right? But before that I will capture here this interface, this 1/3 interface, so that I can see what kind of packet is coming, as I have explained, whether it is true or not, right? I might tell you the wrong thing. This interface, right? So let me capture, this is the ping, right, from here. So right hand side I want to ping the 8.8.8, which is MPLS destinations, and this is the IP packet, right? So let me ping one packet, let me ping from one, and let's see, right? So let me stop, suppose all these stops come, right? Now let's understand this capture, right? Very important. I hope you enjoyed this video if you really love this technology. So what is source? Source is 1.10. To whom he is pinging? He is pinging 8.8.8. So this is MPLS packet we are reaching, right? So let me open that fast. Yeah, so it is very important really. What packet? This is the packet ICMP, right? I did the ping, I sent the ping packet only. Now how do I send? Who is source? Source is 1.10 and destination is 8.8.8. That is fine, but what I said just in last slide, that how do I understand whether it is MPLS or IP packet? With this value, right? With this value. This value says it is MPLS packet, right? This value, right? This value, the PID value, where it is in L2 header, right? It is in L2 header, and the value would be 8847, right? What is the value? 8847. So it indicates that this is MPLS packet purely, right? So it's very clarity, right? All right, so now let me open this part. Now who has ping from this source? 1.1, this is IP packet as I said, and the destination is the 3.3. What I did, I sent the ICMP packet, right, as a payload. Now let me open. Okay, let me open this. Yeah, here it is. Yeah, so here you can see there is no MPLS, right? Let me open one by one over here, both of them. Please bear with me, I might taking time. You can play with fast forward, but whatever you are going to understand, never forget, right? So this is MPLS packet. How do I understand? You are understanding with this value 88 in PID value, right? 8847. This is the IP packet. Source is 1.10 and the destination is 3.10. How do you understand? In L2 header, right? This is the L2 header, right? Or source MAC and destination MAC, where it is mentioned, it stated that 800, right? So it's very transparent and crystal clear, right? Hope you understand. Now you might think, how do you make IP packet and MPLS packet? There is one funda I use for the packet or label. Sorry, it's not packet, it's label filtering, that I will show you later on, right? So hope this chapter is very much clear to you, right? Everything is clear. So we understand this is MPLS header. What is the IP header, right? Now we want to understand more in depth, right? So how do I understand? Let's enter into the MPLS header. Let's get into the MPLS header. Here we are, right? So here you can see multiple values there, right? So only all these value, all the stuffs are considered only MPLS header it is, right? Now you can see over here that is 30 to all around 32-bit MPLS header, right? Separated in 4 part. One is 20 bits, right? 3 bits, 1 bits and 8 bits. 20 bit is responsible for labeling only, right? 3 bit is responsible for experimental purpose, that I will also explain. And another 1 bit is the what I say bottom of stack, that I will also explain. And the rest of 8 bit is responsible for the TTL, that I am not going to explain. It's very common, everyone knows, right? So first understand the label part, right? So in label, if we calculate the 20 bits, right, by using this, we are getting a range of value from here to here, right? So this entire value is multiple meaning is there, right? Multiple purpose is there, right? So let's understand one by one. So the value starts from 0 as it is, but value 0 is responsible for represent the explicit null, right? Value 1, as I mentioned, the arrow mark is represent the router alert level. Any alert need to be sent, this field value will be used, right? And this label will be used, right? If any alert need to be sent. Now what about this 2 value? 2 is represent the IPv6 explicit null, right? So there is two value. One is explicit null, another one is implicit null, right? So I will explain both of them, but for IPv4 and IPv6 explicit null is mentioned, right? So IPv6 explicit null it is, right? That value is reserved to, right? This one, right? Here it is, right? It's represent IPv6 explicit null, and for IPv4 explicit null, that value is 0, right? So 0 and 2. In between, 1 is using for the router alert only, right? Any alert need to be sent for this communications. In that case, they will use value 1, right? Now the most important value is this, right? This value is reserved represent the implicit null. This implicit null is very important. The explicit null is also very important, that I will explain definitely. And other 4 to 15, this value is reserved for future experimental or type of any modification, right? So we'll not consider this 4 to 15, right? Now what about what value left? The value left 16 to 1048576, right? So this is the range. The entire value will be used for labeling purpose. Any APC will be labeled within this value, right? You can change, you can modify this range, that is different, but this value is dedicated and this value is usable. It is not it's not reserved, it is unreserved. It's open for all, right? Now let's understand explicit null and implicit null. Explicit null and implicit null, basically by default it comes with, it's used for signaling purpose. What is signal, that I will explain later on. And what is explicit null, that is also do same kind of purpose. That let me explain over here. Now experimental bit, right? This 3 bit, see this 3 bit, and here also bit 3, right? So now thing is that this 3 bit will be used for the experimental use definitely, but thing is that whenever the QS will be used, this 3 bit will be used on that purpose, right? If you configure any QS on your MPLS network, in that case this 3 bit will be used for the experimental purpose, right? So now thing is that you might think I have MPLS network, right? Multiple network, and I am using what I am using? I am using MPLS network along with QS. I need QS, I have used network, right? In that case, if I use the 3 bit for this purpose, QS purpose, DSCP send purpose, in that case, what will happen with this implicit null, right? This is the problem. In that case, if you are using the QS, in that case you have to use explicit null, that is the value 0, right? And by default implicit null is enabled. Now if you configure, if you use that a QS part, in that case you have to enable LDP enable explicit null. In that case only your null value will work. Now what is null, that I'm gonna explain in next onwards, right, or subsequent slides. All right, so hope you understand this part, right? All this part, right? This 0 is used for IPv4 explicit null, 1 is used for the router alert. These are the value 0, 1, 2, 3 are reserved for a specific purpose, that is fine. And 4 to 15 are reserved, right? And unreserved value or usable value is this range. This diagram is very self-explanatory, right? And now what left? This single 1 bit is left, right? What is the bottom of stack? What is the bottom of stack value, right? let me explain over here. If you are using simple MPLS, in that case only one label gonna use, right? Only one label is sufficient. But if you are using L3 VPN, right, in that case what will happen, multiple label gonna use, at least three, right, three label gonna use. So how do you understand, how do you differentiate this label, which one is label, last label? In that case, if you have the three label, the first label gonna 0, the second label gonna 0, the last label gonna 1. Whenever you see the last label is 1, it's mean that this is the last label, right? And if you see that the level 0, it's mean there is another level which is the bottom. So always one value is as a bottom level, right? That I will also show you, right? And rest of the part is for TTL part. Now what left? Left is only null value, that I will explain, right? Now let me show you this bottom of stack level or the MPLS, this entire header, right? So let me take you to the lab again. Okay, just so what I do, I will ping it again, right? Again I will capture, because without capturing you cannot see anything. Whatever I will explain, you cannot understand. If you have patience, you put your time, lots of things you will understand, lots of clarity you will have, right? So what we will do, we will ping once again, right, to get understand for the MPLS header, right? We get the packet, man. Yeah, so from here we got the packet, ICMP packet. This is the payload we sent using the MPLS header, right? Let me open that, let me explain over here. So what I said, let me go to over here. What I said, this is 2.5 protocol, 2.5 header, which is come in between L3 header and the L2 header. Where it is, right here it is, right? Your MPLS multi protocol is here, where it is in between L2 header and L3 header, right? It's come in between. So here is your MPLS come between L3 header and L2 header. That's what it is called 2.5, right? Now let's expand this MPLS header. What is that? See, bottom of stack level is 1. It means this is the last level, right? So MPLS level he is using 401. It is self-explanatory. Using this level he tried to reach the destinations, right? Hope you understand this part, right? All right, so everything is clear, right? In bottom level, if it is 0, it's mean it is L3 VPN supposed to, and there is multiple level, right? And that I will explain more in detail in L3 VPN other tutorial, right? Okay, so hope you understand this entire packet header, right? Lots of meaning. This picture itself a self-explanatory, right? I prepared this picture to save the time only, right? You can take a snip. So what next? How the label is work? So here we go. Here I will explain how labeling part is work, which is main important topic for you, right? Hope you have patience, right? So let's understand this picture first. So this is network, right? And this is located over here, this 8.8.8 network, and this is the prefixes 16.1.0, right? So how the, as I explained earlier, how the label gets distribute. Label get distribute with unsolidated manner, right? There is no demand, right? There is no request. Now how the label get distribute, let me show you. First this prefixes comes, right? Then this prefixes sends to that PE, right? That PE sends. Once this PE receives that prefix or FEC, he immediately generate a local label. Here I have denoted with the red mark only, right? All right. So after generating a local label, that is red color, I have for the significance for understanding I have mentioned it, then immediately he will send to his P, right? Once this P receives this prefixes or FEC with the label red, he instantly generate another label, right, for him, and he will keep the red label as well, right? The same way he swap the label with the blue, he sends the blue he sends the blue label to another PE, and once this another PE receives that blue label, he will generate another local label with the green, and he will keep the blue label as it is in his database. This is how again he will send the he will again send the same label to that PE with the green label. Once this green label receives that packet, he will keep that green label definitely, but he will generate another local label for that particular prefixes. Then last he will send only prefixes, right? So this is how initially generate the label, right? Now here you might think that I am ignoring this part. What is that? This part is nothing implicit null. That also I am going to explain, right? Very well. So once this label get distributed, once they already right receive this label, how they make their database. As I said, they do prepare one LFIB, right? So this is how they do prepare LFIB. I have significant with signify with the color, but definitely that will be the value, right? Hope you understand. So let's understand very well. Now thing is that label is generated. This part is very important. Please concentrate. So for this prefix, right, for the 8.8.8, right, he generate a local label, right, and out label, his out label, he has also keep which he has received from his pair. That is the local label of his pair, right? The similar way, everybody keep the received label as out label, and the local to the his pair is a local label. This is how they do store, right? This part is very important. For this PE, for this PE, his out label is 401, but his neighbor, his local label is 401. Now why it is so? Let's understand very carefully. Here this router, suppose let's say this router says, this router, if you want to reach this prefix, right, if you want to reach this prefix, you have to reach, or you have to come with this label, local label. This is my label. You have to come to me. I will help you to reach there, right? That's what. Once this label, this packet comes to him, he says to reach these destinations, use the out label green. Then only you can reach the next hop, right? Now once he reach the local label, he also having the one out label. So it's mean to reach the 8.8, you have to go out, you have to use the out label to his local label, his neighbor, right? So this is how it is, right? So this is how get basically flow. Now let's focus this part. Try to understand this part, right? Here I will explain. So if any MPLS packet comes, how it gets flow? It comes through the router, then gets swap. Then he sends the original packet, right, without any label. So what's happened? Again, let me explain. Once he reach, he sees, he check what is my out label. I want to reach this ready, right? What is my out label? This. He will use this label to reach the destination. So he already says, if you want to reach 8.88, please come to me, right? So once he come to him, he will says, if you want to reach 8.8, then go to 302, right? So once he go to 302, he says, if you want to reach, use this level 401, right? So this is how packet gets switched. There is no lookup, only the switch. Immediately the swap, every value, right? So everywhere it is, the label The same way I will also show you in lab, but here is main important part. Here is I am saying the pop level. What is pop level, man? From where it is come, right? It's come from implicit null. Now how this pop level it is, now let me explain over here. You have this router, right? And you have one network x dot x dot x. Now this router knows this x dot x dot x without any label because he is directly connected, right? He can reach without label, right? So for that, what he will do, he will send against that x dot x, he will say this router, if you want to reach this x dot x dot 8, you no need to take headache, right? You no need to take extra activity to labeling, right? You can do one thing, you can remove the label, you can just send the original packet, right? Without label, I can send it out, I can take care. So this router 1 is helping router 2 to take less headache, means less CPU utilizations, right? So it means no need to take send and generate another label, just send me the open packet, right? And send it to me. I will send that packet because I know him without any label and all the stuffs, right? So this is how this happen. Now how this router 2 will understand whether I should pop that label, whether I should remove that label, how he will understand? He will understand by one signal. That signal will be sent by this router 1, right? And what is that signal? That signal is implicit null, right? And that by default value is 3, right? Hope you understand. This is very important part, man. So this value he will send that he router 2, I am sending the implicit null. It's mean you can send me the packet removing that label. So it's mean your next stop is your pop label. So you will send that packet removing that pop, removing that label, popping that label, right? Hope you understand very well, right? I try to explain this way. I will also show you in lab, right? So now thing is that this is how he has reached, but what about he wants to response, the ping response the same way, right? The same way he will packet will goes and it will get swap again. This last in it will pop, right? The label will be removed, right? That thing I will show you in lab. Let me show you, let me take you into the lab, right? Now how do I show you? First thing, multiple thing I have to show you, right? 2 to 3 thing. Please be with me. So MPLS forwarding. Now let's start from here, right? Okay. Right. Right. So here, as I explained, if you want to reach 8.8.8 network, use this out label, right? Out label means he has to reach, try to understand. So this is the level, means his local level, right? Router 2's local level. So let me show you this part also. So here where it is, yeah, his local level is 309, right? His out level to reach over here this network 209, his outgoing level, right? And he is local level 309, but thing is that his out level is to reach this destination. This is the next hop IP address, next hop interface, but level is 308, which is local level of the next hop. Let me show you that part also, right? right? His remote level is 308, then his local level is 308. Because he wants to reach 8.8 network, he has to go to out level, which is local level of this router 2, right? This level. Now he wants to reach the 8.8. To reach that out level is 401. Now who is 401? The next one, right? Let me show you. Here it is. Yeah, his local level it is. Now let me show you again what we earlier saw. This router wants to reach 8.8, so his out level is 401, which is local level of this router. 401, right? But thing is that for this router means the router 4, I said this router, right? So this router, the outgoing level is pop level. Oh my god. So his outgoing level, pop level, it means that he will remove now and on the level, he will send the only IP packets, right? Because he says the implicit null, right? So MPLS LDP bindings, right? So that it is, let me 8.8.8.024, right? So his outgoing level is, remote level is implicit null, you can see, right? Implicit null indicates that it is pop level. Here it is, the next level is pop level, because here the level, remote level, is the null level, right? Hope you understand this part. Now how he understand the implicit null, right? So let me show you how this level gets forwarded, how he understand that he has to remove, because he will send that implicit null value 3, right? Let me capture 1/0. Let me log in this router. Where it is, this is the interface. What I'll do, I will shut down this interface and I will check whether it is sending the implicit value 3, right? Shut, then no, shut. LDP is down, right? Where is the capture? Yeah, here it is. Now no shut, I put the no shut, right? So it's mean it's up. Okay. Initialize keep alive message, label addressing message. Let me stop over here. So let me open. Oh, who is sending? Let's understand. The 8.8 change to 4.1. Perfect. So he is sending level, his distribution level. What level he has sent? Level distribution protocol. This is level mapping message. Which FEC it is? It is 8.8. Now this is the fun, right? Try to understand. He's saying the generic level 3, it means that implicit null, right? So that's what I explained in that graph. He sends implicit null, then only he understand I have to remove this packet without label, right? Hope you understand this part. All right. Right, now you can filter the label, right? How do I make the label IP packet and so run IP packet and MPLS packet? How do I make the 192.168.3.10 is IP destinations? Let me show you that part also. What I did, I have filter, right? So what I said, no label LDP advertise. First I said no need to send any level, right? But again I said one thing, part, that is MPLS LDP advertise label for 1. Now what is 1? Here I said to filter, I don't want any level for this prefixes, and permit any. It means other prefixes he will assign the label. For these prefixes he will not assign any level. So this is how I filter, right? You can filter the level, and by filtering I make this packet as a IP packet, right? And with this command what I did, I chose the interface loopback1 interface as a LDP router ID. All right, now how do you check? So MPLS LDP binding, right? Here you can see for one prefixes there is multiple binding, right? Multiple binding. The remote binding is 403 and 203. This is your level information base, but you have to make the best one, right? So MPLS forwarding is the your LFIB forwarding base. So you have to reach this port. You have two paths, right? Two remote bindings, and one is 403 and 202. Let's see that part. 3.3.3, right? Okay, no, this is this router itself, 3.3, so ignore for now. So I would show you this part. So to reach this destination in LP, you have two labels, outgoing labels, remote binding label or outgoing label, that is the 401 and 209, right? Now how he has chose the 401 is the based on the SAFE table or the FIB table, right? 401 he will only reach the destination using 401, but though he has two different bindings, right? So this is how you can understand all around. Right, now another part I would like to show you, that is the no label, right? Sometimes you might see that no label. When you see the no label, because if any prefix is received from anywhere which is not MPLS not enable, right? So in this section, if the MPLS IP is not enabled, in that case this prefixes will be sent to this guy without no label. Here will be no implicit null. Only implicit null can be generated by the MPLS enable router. Otherwise, if any prefix is received by the MPLS enable router, in that case he will receive with the no label, right? And he will generate one label, then moves forward, right? So this is how basically label work. Another thing I would like to show you, whatever the label you are watching over here, that is customizable. Now what is customizable, right? Let me show you over here. So as I have configured, or I have choose my label range from 100 to 200. This is how you can choose with this command only. You have to put the label range, MPLS label range, then you will get this entire range, whatever I have show you in the header part, right? So you can change as you needed, right? Or you can make the default. Both way you can do, right? So hope you understand the label range, label part, how it gets swapped. And basically the main purpose of this video, to how this label being assigned, or rather the label is get pushed to that IP header, right, as MPLS header. Then how the label is get swapped with the another label, right? Then it's move forward. Then how the label gets pop, how it gets removed from the label, then it sends as a IP packets, right? Hope we enjoyed the video, we understand the video, and we will definitely like this video and share others for helping purpose. Thanks for your time.